Okay, when you integrate a rate, you get a net change. A derivative represents a rate. The antiderivative is the function. You do f of b minus f of a. That's about Monteiro calculus, right? How do we apply that? We talk about this net change. There's a difference between net change and total change, okay? So net change compares where you start to where you are at the end. It doesn't care at all what you did in the middle. It just compares where you start to where you end. So if you are, like running back and forth on your street and you start and end at your house, it's going to say that your net change was 0. You didn't go anywhere. But if you look at your, watch and it tells you you went 3.2 miles, that would be your total change. So there's a difference between your net change. Take a picture at the beginning, take a picture at the end, see how far apart they are. And your total change, which is forward and backwards distance, then they're going to be two different numbers, okay? In net change, when it's moving forward, it's a positive change. When it's moving backward, it's a negative change. If you add them up, you could have 0 change. In total change, you're going to use positive, whether it's going forward or backwards. So you're going to think about using like the absolute value of the function. Make it always above the x-axis and take the total change, okay? So Mr. Brust is driving across town to Mr. Sullivan's house to play with a new set of Star Wars figures. Mr. Brust's speed would obviously vary throughout the drive, but because he's so cool, he came up with a function that represents his velocity, miles per minute, at any given time t minutes since he left his house during the 30-minute drive. Okay, so here's his velocity function. Sine of 0.3t plus natural log of t plus 1 minus 2. That's his velocity function, okay? That tells you how fast he's going. It says set up the expressions for the following scenarios and then just use a calculator to solve. How far is Mr. Brust from his house after 10 minutes? So how far is he after 10 minutes? If you want to get his position from his velocity, what do you have to do? Take the antiderivative, yes. If you want to find out how far he is after the first 10 minutes, what are your limits on your definite integral going to be? 0 to 10, right? So we're going to start at 0. We're going to go to 10 of this function, sine 0.3t natural log t plus 1 minus 2 dt. We could do this by hand, but we don't have to, right? We can use the calculator or Desmos to find this definite integral. It's going to be some number, right? What do you notice about his velocity at the beginning? It's negative, right? Because it's below the x-axis. So he's moving like backwards, like maybe, he lives like on that windy street in San Francisco or something, right? So he goes backwards and then here he starts to move forward, right? This scale goes by 5. So 10 minutes is somewhere at this second tick mark. So this integral is going to give us a negative plus a positive. He's not going to be very far forward from his house, right? Like maybe he drove backwards towards the grocery store and then the other way, okay? So when we get this integral, it's going to be only a small positive number. Okay, I'm going to pull up Desmos. And let's do this integral in Desmos. Okay, integral 0 to 10 sine of 0.3t minus, was it minus? Minus natural log t plus 1 minus 2 dt. Look at that, negative 29.7. Did I get it right? Oh, it's a plus. It's a plus. See, it's a plus up here. Plus. Okay, 3.01. Okay, 3.01. 3.01 watts? Miles. Velocities in miles per minute, right? So this was this velocity function, sine the natural log 2 is in miles per minute. T is in minutes. So when I do miles per minute times minutes, I end up with miles. So he's 3.01 miles from his house. Okay, then it says, how far is he from his house after 15 minutes? What do I change to figure out how far he is after 15 minutes? Yeah, just change the top number to 15. They're called the they're called the limits of integration, but we don't distinguish between top and bottom. They don't have their own names, unfortunately. We could just say the top limit and the bottom limit. Okay, so I'm just gonna go change that guy to 15. Let's look at the graph again for a second. And tell me, at 15, do you think he should be farther from his house or not? So we went to 10 here, right? And then 15 is here. What do you think happens? Remember what tells you how far he is from his house? What about this graph tells you how far he is from his house? What does the y-axis tell you about this graph? How fast he's going. What about this graph tells you how far he's traveled? The area, the antiderivative, the area under this curve, right? So from 10 to 15, he has this much positive area and that much negative area. Do you think his total distance is going to be more positive or is he going to get negative? You think that it adds negative? You think that this area down here is bigger than that area right there? I think that this area here is probably a little bit bigger than that one, right? So he should be farther than 3.01 miles from his house because this area here above the x-axis is slightly larger than that area there. What about when he goes all the way to 30? A lot farther, right? Like here at 10, he's 3 miles away. At 15, we think he's a little bit more than 3 miles away because he adds a little bit more. He takes some off, but he adds a little bit more. But by 30, he adds this huge amount, right? That's when he's going to get the most. Okay, so when we go to 15, we think it should be a little bit bigger. I didn't change anything yet. 3.39, 3.4. If Mr. Brust arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? How do you figure out how far away he lives? Yeah, you just find out his total distance, right? So that doesn't tell you how far his car drove. It tells you if a crow flies from his house to the other house, that's how far it would be, right? So 0.30 just tells you straight distance. If he doesn't have to go backwards ever or anything. So sine 0.3t plus natural log t plus 1 minus 2 dt. So I'm going to change that to 30. We think it's going to get much larger, right? Because in this graph, a lot of the area happens here at the end from 20 to 30. $22.82. Okay, so those were all net change problems, right? When you integrate a rate, you get a net change. It just tells us the distance from where he started to where he ended. It doesn't tell us what he did in between, right? If I walk back and forth, pacing in front of this chalkboard, and all you know is where was I at the start of class and where was I at the end of class, I may have never moved. But I did a lot of, steps walking back and forth. So this last question asks, how many miles did he drive? So how am I going to compute how many miles he drove? And there are a couple of correct answers to this. How am I going to compute how many miles he drove? I could use absolute value. Yes, if I use absolute value, what absolute value does is take every negative thing and make it positive. So it's going to put this guy up here and it's going to put this guy up here. And then I'm going to compute these areas. Okay, so one way to do it is to use the absolute value of the velocity. Okay, one way to do it is to use the absolute value. So one way to find total distance is to use absolute value. Or total change is to use absolute value. Doing that is kind of like saying, I'm going to integrate from here to here, and I'm going to take, that number is going to be negative. I'm going to make it positive. I'm going to integrate from here to here and use it as is. I'm going to integrate here, make it positive. I'm going to get integrate here, use it as is. So another thing I could do is find out what points these are and break it up into 4 different integrals. I could go from 0 to this point, from here to here, here to here, and here to 30. Okay, so I could do this integral. I know it's going to be negative. I'm going to take the positive value. Then do this integral, do this third one. Again, I know it's going to be negative. I'm going to take the positive value. How would I find out what these points are here? How would I find out what those x values are? Set it equal to 0, right? Just like put it in Desmos and see what those points are. Okay, so 2 ways to do it. Desmos lets me put in an absolute value. Do you think it should be more than 22.8 miles or less? More, right? Because we saw that there were some points when his car was going backwards. We don't know why, but we saw that there was. Okay, so I'm going to make this to 30. And I'm going to put absolute values in here. Absolute values. Whoops. Absolute values. Okay, the other thing I could do is graph this function. Oops. From 0 to 30. I need this point, and that point. Yeah, so I could do this as 4 different integrals. I could integrate from I can integrate from 0 to 2.362 of my function. This is going to be a negative number. I'm going to make it positive. Plus, I could integrate from 2.362 to 12.686. Use that number. Plus, I could integrate from 12.686 to 17.2. This guy's going to be negative. Make him positive. Plus, integrate from 17.2 to 30. Okay? The other way to do it is break it into 4 pieces and just make them all positive numbers in the end. Or put this absolute value function inside of Desmos. That's way easier, right? But you know, you might not always have Desmos. Okay, so we did, oops, make a new share. Integral, we would, yeah, but the ones that are negative, you gotta make them positive before you add them up, yep. Space. I forgot the answer. 28. $28.5. Miles of driving. So the distance between net change and total change, the difference between net change and total change. Net change uses the positive and negative. Total change does not. It says make everybody positive and see how far. We don't care about direction when we're doing total change. When we're doing net change, we do. Okay, so which one's which? When I integrate velocity, I get net change. Net change in position. When I integrate the absolute value of velocity, I get the total distance traveled. I don't know why there's that weird space there. Oh, I know. If you do the absolute value, we call it the speed. You could put in the integral of speed. Velocity has direction, speed does not. Oh, net change is sometimes called displacement. So the integral of velocity gives you displacement or the net change in position. The integral of the absolute value velocity or the integral of speed is the total distance traveled. Okay, this guy here is a graph of the velocity function. I'm going to ask you some questions before we solve any of this stuff, okay? So this is a particle, it's just moving along a line, right? Imagine it's just me in the front of the room walking back and forth in front of the whiteboard, right? When am I moving forward and when is it moving backwards? So when is this particle moving forward?
When the graph is positive?
Yes, when the graph is positive, right? When the graph of this velocity function is above the x-axis. So this particle is moving forward on what intervals?
0 to 2.
0 to 2 and 7 to 10. Yes? What's happening from 3 to 6? It is constant. It is a constant velocity. Is it a zero velocity?
No.
No, it's a constant velocity in the negative direction, right? So be careful because oftentimes when you look at this graph and you see this, you say, oh, the particle wasn't moving. That's not true, right? This is a graph of the velocity function. Unless it's at 0, this particle is moving. Here, it's moving at a constant speed. Here, it's like decelerating because the velocity is negative, right? So it's slowing down and then speeding back up again. So we would say like this guy is an inflection point. The concavity changes here. And we're going way back, right? That happened after the midterm though. So that's what we have to have a test on next week. Okay, so this guy is moving forward from 0 to 2. He's moving backwards from 2 to 7. He's moving forward 7 to 10. Okay. It says determine the following. Notice that his initial position is at 1. Right here. His initial position is at 1. That might be important later. Okay, let's just remember that. His initial position is 1. Find me the displacement between t equals 0 and t equals 10. So what am I looking for if I want to find the displacement between 0 and 10? The integral from 0 to 10 of the velocity function. The problem is I don't have an equation for this velocity function, right? So how am I going to find the integral? I'm going to like use shapes, right? Remember using the shapes that we did like last week? So I need like, I don't know, a couple of shapes. If you know the area of a trapezoid, you might only need 3 shapes. I never remember it, so I won't use it. But if you know it, you could use it. I'm going to use, I guess, 5 shapes. I'm going to use one triangle here from 0 to 2. I'm going to use this tiny triangle from 2 to 3. I'm going to use this rectangle from 3 to 6, another triangle from 6 to 7, and then this last triangle from 7 to 10. If I'm doing the displacement, do I care whether the triangles are above or below the x-axis? If I'm doing the displacement, do I care whether the area I find is above or below the x-axis? Yes, I do. When I'm doing displacement, I use above as positive and below as negative. Okay, so I'm going to find all these areas. Let's do that. Let's see, this first one is a triangle, base 2, height 2. So 1/2 base times height gives me 2. That guy is 2. I'm going to do this last one. 1/2, this guy is base 3, height 2. So this guy is 3. Yeah. Now I'm going to do this one right here. And it looks like it's the same as this one right here. Do you agree? Yeah. Okay. So 1/2, whoops, base 1, height 2. So this green guy is 1, and this green guy over here is exactly 1 as well. What's this last shape? A rectangle, yeah. So base 3, height 2 makes 6 here. Okay, so my total displacement is going to be what? It's going to be negative, right? 2 plus 3 minus 8. 2 plus 3 minus 8. The yellow ones are positive, and the green ones are negative. So my displacement is going to be negative 3. Different question then. What was my distance traveled between 0 and 10? So the particle started. Yeah, add them all up, right? It moved forward 2 steps. It moved backwards 8 steps. It moved back forward 3 steps. You can see the difference between where it started and ended. If you want to find out how many steps it took, you just add them all up. So we're doing integral 0 to 10, absolute value v of t. So 2 plus 3 plus 1 plus 6 plus 1. 13. Is that what someone said? Okay, the position at t equals 10. I want to know, where is this particle at time 10? How am I going to figure out where this particle is at time 10?
Add up or like add and subtract.
Yeah, add and subtract the positions from,
0 to 10.
yes. What else do I need to include? The initial position. Remember I warned you at the beginning? Remember that where this guy starts, right? So let's go back. This guy starts at s of 0 equals 1. So at time 0, he's at 1. So let's draw the x-axis here. Okay, I'm drawing the x-axis. At time 0, this particle starts here at 1. Yeah, what does this particle do? It goes to the right, forward, how far? 2. Because of this guy here, this 2. Okay, and then what does he do? Turns around and goes backwards 8. Yes, because I have 8 done here. So he turns around, he goes backwards 8. So where is he at time 7? Where is he at time 7? Negative 5. He was at 3 and he goes backwards 8 units, right? So now he's at negative 5. Okay, and then what does he do? He turns around, he goes 3 to the right. So he's going to end up here at negative 2. Yes. So this 2 here was these 2s. And then this long line is negative 8, all of those guys underneath. This short line is 3. Yeah. So remember, we said that his change in position was -3. So what I could have done is taken his starting position and subtracted or added the change. So 1 minus 3 gives me -2, which is where he ends up at, -2. So this particle ends up backwards from where he started. So you should be able to find his position at any time, right? Like I could ask you, where is he at time 4? If I ask you, where is this particle at time 4? All you do is say, I'm going to add 2 and subtract 1, 2, 3, add 2, subtract 3, because I only want the area up through 4. So think of it as he's just moving back and forth. How do I find out where he ends? This starting point is important, right? You can't assume that it starts at the origin. You got to say, where did he start before he started walking? Okay, starting with an initial value of P of 0 equals 10. The population of a prairie dog community grows at a rate of P prime of T equals 10 minus T over 2 in units of prairie dogs per month for 0 less than T less than 20. What is the population 8 months later? So how am I going to find the population 8 months later, do you think? That's a good thought, yeah. Probably I should use an integral. Which integral do you want to use? From 0 to 8, yeah? From 0 to 8 of this rate. Will that tell me the population 8 months later? No. What will that tell me?
It tells you the change.
That tells me the change in population in the first 8 months, right? Okay, so I definitely am gonna need this integral. This is an excellent thought. I need this integral from 0 to 8 of P prime of T. That's gonna tell me the change in population in the first 8 months. This says, what is the population? Yeah, so I'm going to take the initial value, whoops, P, we're using P's now, not S's, P of 0, and add the change. If it's a positive number, it's going to go up. If it's a negative number, it's going to go down, right? So when I integrate this thing, if I get a positive number, the population is going to go up. If I get a negative number, the population is going to go down. I'm going to find that integral. That tells me the change. That's not my answer. That's how much different it is. You use the starting point, and then you add the change to it. Okay, let's integrate this guy by hand. That'll be fun. 10 minus T over 2 dt. Do you remember how to do a definite integral? How do you do a definite integral? Okay, 10t minus, yeah, add 1 to the power and divide by the new power. So 2 divided by 2 makes 4. From 0 to 8. How do I do it when it's a definite integral? Plug in 0, plug in 8, subtract. Which one goes first? 8. Yeah, plug in 8, plug in 0, subtract. Okay, so I'm going to get 10 times 8 minus 8 squared over 4 minus 10 times 0 minus 0 squared over 4. This guy's 0, so he doesn't matter. 80, 64 over 4 is 16. 80 minus 16 makes 66. Someone should put that in their calculator. Well, this number, 10 times 8 minus 8 squared over 4. Okay. 80 minus 16 has a 4 at the end. Yeah, you're right. Definitely has a 4 at the end. Okay, what is that 64 again? The change in prairie dogs in the first 8 months, right? So the population added 64 prairie dogs in the first 8 months. Yeah, it could mean that they had 70 births and, 6 deaths. We don't care. All we know is that in total, the population went up by 64 prairie dogs in the first 8 months. If I want to find the total population 8 months later, I'm going to take that 64 prairie dogs and add it to the starting 10. There were 10 here when we started. So 10 plus 64 new ones means 74. I can't spell prairie. Prairie dogs after 8 months. Okay, part B. Part B says, find the population P of T for 0 less than T less than 20. So this one wants a function, yeah? All the problems we did so far today just wanted numbers and answers. How much change was there? What was the total displacement, right? This one wants an equation. You don't need to know any of the stuff we learned today to solve this question. You could have done this like 2 weeks ago. How do you find the population if you know what P of T is? Do just an indefinite integral, right? I'm just going to do an indefinite integral. P of T is the integral of P prime of T. The integral of 10 minus T over 2 dt. Okay, what do you get when you integrate 10 minus T over 2 dt? 10T minus T squared over 4. Plus C. Remember, when we did indefinite integrals, we got a plus C at the end. Can you find this C? Yeah. How are you going to find this C? Yeah, use the fact that P of 0 equals 10. Right here, use the fact that P of 0 equals 10. So when T is 0, P equals 10. So 10 equals 10 times 0 minus 0 squared over 4 plus C, means C equals 10. Okay, so my function P of T is going to be 10T minus T squared over 4 plus 10. If I want to find out how many prairie dogs there were after 8 months, I should be able to plug 8 into this equation. That's what we did before, right? We plugged 8 in. This guy canceled out because he was 0. We added that initial 10 prairie dogs. Now, if I want to find out how many prairie dogs there were after 15 months, I can just plug 15 into this equation. I don't need to do these definite integrals over and over again, right? So that's what the difference between a nice equation compared to doing definite integrals and adding every time. Okay, it's quiz day. Take your 2 quizzes. D2L quiz number 12, grade scope quiz number 11. We're doing area between curves on Wednesday, and that's our last new topic. Friday is a homework day, Monday's review day. The final exam is Friday the 19th from 11 until 1:30. So 11 to 12 will be the grade scope portion, 12 to 1:30 will be the Edfinity portion.
Okay, is that on?
That's Friday the 19th.
Okay.
Yep, so 1 week from Friday.
We're
So
only gonna be doing homework this Friday.
this Friday, you just have homework due, yep. And then Monday, you have 1 more grade scope quiz. And then the final exam Friday. It's at home though, right? It's online. So 11 to 12 will be your grade scope part. 12 to 1:30 will be your Edfinity part. See you Wednesday.
You said the final is like roughly the size of the picture.
Yes, I would very much say that. I don't remember how